The model checker is a feature in BIM EMS that allows for checking BIM models against particular rule sets. To open the model checker, a complex needs to be selected first. Then, the BIM tab has to be opened. Now, a model needs to be selected. Pressing on a model in the list will open the 3D viewer. Opening the model checker can be done by hovering over the Model Checking button in the toolbar and pressing the Open Checking Configuration button. Now that the model checker screen has appeared, a rule set has to be selected before proceeding. This can be done by pressing on the Load Rule Set button. The desired rule set can now either be chosen from the list of existing rule sets or imported from a local file. The selected rule set can now be applied by pressing on the Load Rule Set button. Running a check using the rules within the rule set can be done by pressing on Run Checks. After running the model checker, the results are shown in a new window. The way that the results are shown is determined by the settings for the selected rule. The following scenario will show how to create a custom rule for listing an overview of the number of spaces within a building grouped by zone. If desired, a new rule category can be added first by pressing on the Add Rule Category button. For this example, the category will be called Overviews. Now that the category has been added to the list, it needs to be selected before adding a rule to the new category. Adding a rule can be done by pressing on the Add Rule button. This opens a window for selecting a rule template. In this case, since the desired outcome is to list all spaces within a building, the Components per Building template will be used. To customize the created rule, it needs to be selected. This can be done by pressing on the name of the rule at the left side of the window. If necessary, the name and description of a rule can be adjusted by pressing on the Change Name and Change Description buttons, respectively. In order to select which components the model checker will run the checks on, a new row has to be added to the Required Components table under Control Parameters by pressing on the Add a New Row button. As displayed on the screen, the table contains multiple columns: the building filter, that determines which buildings to run the check on, the target filter, which can be used to search for specific components within a building, and lastly, the minimum and maximum count, which are optional fields that determine how many components should be included when running the checks. If the amount of components found are either lower than the specified minimum or higher than the specified maximum, a warning will be shown when viewing the results. The minimum or maximum count can be ignored by setting its respective value to 0. For this scenario, the default setting will be left for the building and target filters, since the goal is to find all spaces within a building and eventually group them by zone. In case the building filter or target filter has to be adjusted, this can be achieved by pressing on its respective Edit button. For example, when adjusting the target filter, the IFC component to search for and the type of filter to use can be selected. Right now, the default settings will be used so that the model checker will search for any space within the building. After setting the control parameters according to preference, the checks can be run. This time, the results simply show all IFC components within the building. The Group By function can be used to manually group components by specific categories, such as by zone. This can also be done by adjusting the reporting parameters for this rule. These are settings that determine how the model checker reports to components that are specified in the Required Components table. Firstly, a new row has to be added to the Reporting Properties table. by pressing on the Add a New Row button. This table consists of the following columns. The component filter. This filter determines which components to apply the respective reporting property to. The property field. This setting decides which property to add to the report. For example, this could be the name or the area size of a component. The grouping by field. This determines by which categories the components are grouped. And lastly, the operator field. This field decides which operator is applied to the specified property. Changing the component filter can be done by pressing on the Edit button. This will be left to the default setting, since all IFC space components need to be grouped by zone for this scenario. In this case, the property field can be left empty, because the desired outcome here is to simply count all IFC space components in each zone. Adding an extra property will therefore not be needed. Next, the grouping by field needs to be adjusted by pressing on the respective Edit button. The grouping type will be set to relationship, and the value in the dropdown will be set to zone. This will cause the model checker to group components based on their relationship to a specific zone. Lastly, the operator field can be modified. For example, this can be used to list components on a certain property, count the amount of occurrences, or calculate the sum of multiple values. Here, this value will be set to count, so that the amount of spaces in a zone can be determined. Now that the reporting parameters are set, the checks can be run again. This time, the results table shows an overview of zones, including the amount of spaces within each zone. Aside from this example, the model checker can be used for other purposes as well, such as checking whether components contain the required properties, ensuring that the height of a building is within constraints, or to determine whether the area of a space inside a building does not exceed its limits. For more information, visit demo.bimkeeper.com or reference the BIM EMS manual. The links can be found in the description.